Chapter 17, Part 5. So we tilted this box. We have the corners here. We need to make this 2, and we need to make this 1. So we need measuring points. Just like finding the measuring points up here, where we took the distance from the vanishing point to this vertical axis point, we swung that up to the line that the vanishing points are on. We do the same thing here. We're going to take the distance between the vanishing point and the spot you get your true angles from. And we're going to take that distance and we're going to put it on this line. We can swing it up or we can swing it down. So either one of these points will work. I think we'll try this one. This one I will label the 30-degree left vanishing point. Let's find the measuring point for this vertical vanishing point that is way off the page. Now we've done this a few times. Take this piece of paper, put it under here to make this a little more clear. So this vertical vanishing point is way off the paper. The measuring point for this would be in between this point and this point, in between the right reference line and this left vanishing point. It's going to be between these two in degrees. So we can take a protractor and put it here, find that degree, and then project it up. Or you can do this. Take the distance between this right axis point and this right reference line and swing it over. Then take a 90-degree angle line from the line that connects the right axis point with this left vanishing point. And that gives you the spot that is right between these two angles in degrees. So this is going to be our 30-degree vertical measuring point. Now we have our measuring line here. This is the one we need to use because this is parallel with the line that the measuring points are on. Let's back up a little bit and talk about this. See this left vanishing point? The measuring point is here on this horizontal line. The measuring point and the vanishing point, they need to be on the same line. If we took this distance and we swung this up and stopped here, and put my measuring point here, the measuring point for this could work. You could put it here. They're not on the same line. They have to be on the same line. So the line that they are on, I just haven't drawn it on this. This would be the line that the left vanishing point is on, and the left measuring point. This would work for this. But what would happen is that you would need to add another measuring line to this drawing. It would have to be here. It has to be the same angle as this. So it's kind of silly to do this because you're adding an extra line here, an extra measuring line. It just makes it unnecessarily complicated. So I just wanted to point that out, why we don't put this left measuring point on the horizon line. When for this one, it's on the horizon line. And then when we scoot it down here, we put the measuring point over on this angled line. When we put this measuring point here, then we use this measuring line. So this point is our corner. We want to make this 1, and we want to make this 2. Our measuring line is here. It's not at the same plane as this. This line that we drew from here to here, all of this is on the same plane as this line. This is 2 units away from being on the same plane as this. So we can measure this here at this plane and then project the lines over. We've done that a few times. Or we can take this measuring line and we can move it. Move it so it touches here. Let's do that. I'm going to put this on an overlay. I'm going to do this in 2 steps. I'm going to move the measuring line back to here, and then I'm going to move it over to here. So we can do this with a reference point. I'll take this 0 and move it to here. And there's my reference point. And I know I want this to be 1 and this to be 2. So I'm going to take this line and put it here.
1, 2.
So here's 1, and here's 2. So now I'm going to take this and move it back to here. I already have this orange line that goes to the right vanishing point. So first I'm going to make a line that's parallel to this line and this line, and bring each of these units back. Now I have my measuring line to the right scale. I want this to be 1. I'll use this for my left vanishing point. So I count over 1. And that is 1. This needs to be 2. And here is my vertical measuring point for that vanishing point that's really far away. And here's 1, here's 2. There's 2. And from here, it is connecting dots. And there's this box falling over. The top half of this box that we scooted over, it looks very long here, but it is coming toward you, and this one is going away from you, and this is pretty far outside the cone of vision, so it's getting stretched out, it's getting distorted. Let's put the cone of vision in, and we'll see how these objects relate to the cone of vision. So here's our cone of vision. This one barely makes it, and you can see how far this one is. So that's what happens. Things get stretched out and distorted when they go outside this cone of vision. So staying inside that cone of vision all gives you a little more reasonable results. So these look a little bit closer to being the same size. This is also the same size as this one, but you can see how stretched out it looks going so far outside the cone of vision. Don't quite like that tangent right there. So let's do worm's eye view next.